Okay, this is a second example of working out the force within members, working out the reactions using the method of joints. So again, the first thing that you would be doing is looking at the external forces only to work out the reactions, and we need also the angles to work out the member forces. So you need to practice your trigonometry to work out the angles, and I'll go through quickly some of the angles for this truss here. So you draw your free body diagram. So we've got a truss here with a number of members. Again, it's labelled up A, B, C, D, E, F, G. We've got a pinned joint support here, and we've got a roller support at E. I've drawn my truss. The things that I know is that I have 12.5, 12.5, 12.5 and 12.5. I've got that these are spaced 2 meters apart, so it's not drawn at scale. A, B, C, D, E, F, G. Now, our reaction at E, we have a roller joint. Whenever you have the roller joint, you will have a force perpendicular to the rollers. So we'll call that, what we call it, EX. In terms of the direction of the reaction, if I took moments around A, so if I put my finger down there, and if I imagined all of these forces are pushing my triangle around clockwise, my external force, the reaction EX, needs to be counteracting by giving a clockwise moment. So that's why I've got to go round to the right. Similarly, if I take moments around E and try to work out, well, I've got these 12.5 that again are trying to take everything around clockwise. So my AX is likely to be going to the right. I have got an AY. Now you have to be careful that you don't get confused in between the force that is in this member AE, so this is AE, and AY, which is the reaction force. Now if you looked at the forces on this truss in a vertical direction, you've got these 12.5s coming down, so AY is going to be going up, so AY is going upwards. Next, work out my angles, and I must say this is quite a tricky one for working out your angles. We just draw our triangle there. It's 6 meters across the top, it's 2.5 down there. Again, it's up to you how you want to try and work out your angles. We call it angle alpha, and I use the cat sat on an orange and hurt himself or herself. So if I've got an opposite and an adjacent value, an O and an A, an O and an A, I can work out my angle. These are the angles: tan, cosine, sine. You'll have your own system within maths to work out that. So I'm going to use my T is O over A, so T equals opposite over adjacent. So I do my opposite, 2.5 divided by 6, inverse tan it. it gives me, so if I inverse tan this, I get alpha equals 22.6. So this angle here is 22.6. Now you'll see as we look at each of these joints that the angle GD, that is also 22.6. This angle here is 22.6. Again, this angle FG is 22.6. So you need to try and become familiar with how you work out angles. We'll also work out this angle here, and we'll call that gamma. So in terms of gamma, we've got AB there and straight down, so we've got 2 and 2.5. Work out what gamma is. It's inverse tan of 2.5 over 2. Our gamma becomes 51. Right there, 51.34. That's what our gamma is. If we've got a gamma and we've got a 90-degree triangle, we can work out what this beta is, this beta angle. Beta equals 180 degrees in a triangle. Take away 51.34. Take away 90. Our beta is 38.66 degrees. I'll also be working out the angle, and we'll call that theta. That's 39.81, the angle there. That's just based upon similar triangles. That ends up being, this length here becomes 1.67. So I intend you to understand how to work out your angles. Now I know what my angles are, I can start looking at the reactions. So let's see what we can do here. So 1, we've worked out the angles, sort of 2 is the reactions. And our reactions are at A and E. So we can draw out the triangle that we have. We've got AX, it's an AY. These are the forces that we're considering. You only consider the external forces. And then you've got these 4 12.5s. Now we don't know what AX is, we don't know what AY is, we don't know what EX is. We've got our 3 formula that we can work with. Some of moments around a particular point are 0, some of forces vertically, some of forces horizontally equals 0. It's all about this triangle. This truss is going to stay in one place. How do I get rid of AX and AY? Take moments about a point that they are passing through. If I took moments around A, AY is passing through it. So if I've got my moments equals force times distance, even if AY has a value, because the force is passing through the point A, the distance is 0. a force times 0 means that the moment is 0, so you ignore this AY. AX is also passing through 0 and passing through A, so therefore it's 0 perpendicular distance. So let's take moments around A. So about this point, the perpendicular distance from this point to this force, so this is my force AX, and the perpendicular distance to A is 2.5, the depth 2.5, so all that equals 0, so we've got AX, and I'll put my distances in brackets again, 2.5, and I'm saying that everything that is going about A, so this AX is going to be sending my triangle around anti-clockwise, and I'm saying that everything that is going anti-clockwise is positive. So you've got your AX, ignore AY and AX, and I've got my four 12.5s to consider. Now this 12.5 is acting straight through A, so we ignore it. Again, 12.5 times the distance 0 just gives us 0. So we got our first force here, minus 12.5 times by the distance 2. We got 12.5, this one here, times by the distance 4. And you've got the last one in the corner, 12.5 times by 6. All of that equals 0. AX equals 60 kilonewtons. It's positive, so therefore I've guessed the direction of my AX correctly. I could take moments around AX, that would take out AX from my equation next, and because AY passes through that, it would also remove AY, so I could work out what AX is. But let's use one of the other equilibrium equations. Sum of forces in a vertical direction equals 0. And we'll say that everything going up is positive. So looking at the forces here, we've got 12.5, and there's 1, 2, 3, 4 of them. There's 4 of them. So I've just put 4, no, like 4 number of them coming down. Going upwards, the only upward force is AY. So AY is 4 times 12.5 equals 50 kilonewtons, and it's going upwards. If I sum my forces in a horizontal direction, I'll see everything going that way is positive. Got AX is positive, got A is going the other way, so equals A. Or another way of writing it would be AX is going that way, minus A because it's going to the right, that all equals 0. So AX is the same as A. AX is 60 kilonewtons, AX equals 60 kilonewtons, and it's that way. So we can draw these onto our free body diagram. So we've got 60, and AY 50. We've got AY and AX of 60 kilonewtons. Next three, we'll work out what the forces are, and we have to look at each joint, and all of those in red are those that I don't know. So I can start at any joint. I could start at D because there's 2 there. I couldn't start at G because I've got 3 unknown members. I've got 4 at F, so it'd be silly to start there. We will start possibly at A. E, you've got 3 there. So let's start at D. So looking at D, we've got a 12.5 joint D. We have a 12.5 load at that point. We ignore all of the forces that are anywhere else on the frame. We have this member CD. We have a member GD, and we've got this angle 22.6. Now looking at these 3 lines, 12.5 is coming down. In order to keep joint D in that location, FGD must be pointing upwards. If I looked in a horizontal direction, FGD is going to the right, so therefore FCD must be going to the left. If I look at some forces, and I say that everything that is going up is positive, I've got my FGD, and again I'll just draw this off at the side. FGD, if that was the hypotenuse, how much of that FGD is acting straight up? Imagine that it's just a triangle, it's opposite the angle, so it's FGD sine the angle 22.6. So you've got this one here. You ignore FCD because it's horizontal, because we're looking vertically. Going downwards is our 12.5, all of that equals 0. You can take 12.5 on the other side of the equal sign, divide by sine 22.6. FGD equals 32.5 kilonewtons. The actual line itself, it's like that. Arrows pointing outwards, so it's compression. Remember, FGD is in compression. Some of forces vertically, saying that everything going that way is positive. FGD, this member again, how much of the GD is acting horizontally? FGD is sine 22.6. How much is the 12 is acting horizontally? None of it, so you ignore it. And you've got the FCD. That's going the other way, so it's minus. FCD equals, put that FGD into there, gives you the FCD. 30 kilonewtons FCD, the arrow is pointing inwards from D. It's in tension. I'll draw them. So we got FGD inwards, 30 in tension. 32. .5 in compression. Got them the wrong way around. Easily done. this one here is 30 in tension. It's important to note which way your arrows are pointing so that when you come to your next joint, joint G, you can easily transfer your information from one joint to the next. So we're going to be carrying forward this GD to point G. So joint G, and joint G. So we've got likes of got like F down here, G there, and D's up here, and that's C. So we're looking at G, so we just worked out that FGD is 32.5, arrows are pointing downwards, outwards. If you were going to look along this plane here, FGD is pointing to the left, FG is highly likely to be going to the right, and actually CG, you're not really sure which way it's going, so we'll guess that it's going upwards. So let's see what we've got. So we're analysing this joint G with this 32.5 that we know, and we don't know what that is, and we don't know what that is. Now, if we look at the sum of forces say that everything to the right is positive, what we do, we remove CG, so it removes CG because CG is acting purely horizontal. So if we look horizontally, then it removes CG. If we look at force in FG, how much of that is acting horizontally? We have an angle of 22.6 here, so it's cosine 22.6, that's the FG. The other force that we have at this joint is 32.5, and again it's cos 22.6. You can remove cos 22.6 from either side. FFG equals 32.5. It's pointing outwards. It's in compression. Now if I draw this G again, now FG is parallel to GD. If we analysed forces parallel to FG GD, so So if we looked at forces that way, perpendicular to GD and FG, you'll see that the only force that we can include either side of these two lines is CG. CG acting by itself. So if the way that we can write that, we can sum of forces perpendicular to that line equals 0. Our CG is the only force there, so it equals 0. So CG equals 0. Our FG is 32.5 in compression. Worked out that one. We've got two unknowns at C. We've just worked that one. We'll move to C. Let's draw it out. C. We've got this 30. That's FCD. We've got a 12.5 coming down. We've got CG, which is 0. And you've got CF. So we don't know what CF is, and we don't know what BC is. Now if we looked across the line vertically here, we've got 12.5 coming down. These two are not having an effect trying to keep C vertically. So if 12.5 is coming down, it means that FCF must be going up. But what we'll do, we'll draw it pointing downwards just to see what values we come out with. And we've got our 30 going off to the right, so we'll guess that FBC is pointing to the left here. So let's work with this. So this is joint C. Joint C. Always remind yourself where you are and what you're working on. It certainly helps when someone is having to check your work. Engineers have to check your work afterwards, and it makes it easier for me to check your work. Sum of forces. Sorry, we'll do we'll do a Y direction first. Now what have we got here? We're saying everything that's going up is going to be positive, so we've got 12.5 coming down. We ignore the BC and the 30 because they're horizontal. You've got the 0 there. And we're saying that CF is also going down, so we've got FCF. How much of that, if that was the hypotenuse, how much of that is acting vertical? It's sine 39.81. We've worked out that angle there was 39.81. We worked that out before. Well, that equals 0. FCF ends up equaling minus 19.53 kilonewtons. What this means is that we have our arrow the wrong way around. FCF. So that looks like, we were saying that it was going to be in tension. That's if you have a minus in front of it. FCF actually equals 90.53 kilonewtons in compression. So to correct this, let's draw our arrow going upwards. We would adjust this formula, but we now know that we definitely have to have CF pointing upwards like that. 19.53, and it's going to be in compression. You know, so we did guesstimate that it was that way. It may be better to keep, actually maybe better to keep the original guesstimate and highlighting that FCF. And that's the correct direction for FCF. Let's sum our forces vertically. Sorry, I'm mixing up my X's and my V's. As long as you know, sorry, horizontally, as long as you know what you're doing. Hard to be honest. So what we've got, so looking this way, we've got 30. You ignore the 12 because it's vertical, you ignore the 0. We've got this CF, so we got moving this direction is going to be positive, so we now know that FCF is actually going to the right, so we got and got your angle 39.81 there, so we've got cosine 39.81 minus FBC, which is acting the other direction. All of that equals 0. We know what FCF is, so we can work out what FBC is. FBC equals 45.0 kilonewtons. We're saying that FBC is pointing inwards, so it's tension. FBC pointing inwards, 45 T. So we've now worked out C. We've got 3 unknowns up here, so let's not go to B. We've got 2 unknowns down at F. So let's look at joint F. What joint F looks like. So we've got F here. .53. .5. Okay, let's see what we've got to work with. So this is FC, that's F, G, F, E, F, F, B, F, force Fg. This angle here is our 22.6. The angle from the horizontal to FFC, theta, is 39.81. FBF is vertical. Now looking at these again, if we looked sort of horizontally, they're both coming to the left, so I'm guessing that FEF is going to the right. If you looked across FEF, FG, that's coming down, so let's assume that FBF is going upwards. Sum of forces plus FAF, this one here, again that's 22.6 degrees. So this FAF, if I draw that again there, so we've got 22.6. How much of that hypotenuse is acting horizontally? This angle times by cosine. Cosine 22.6 minus, we have this 32 going to the left, 32.5 cosine 22.6 minus, also going to the left, is our 19.53. That's your FFC, cosine 39.81. All of that equals 0. The only thing that we don't know is FEF. FEF equals 48.8 kilonewtons. The arrows are pointing outwards, so it's in compression. We're getting there. Sum of forces, y direction, I'm saying up is positive, over equals 0. Right, well, we've got FBF, FEF, how much of that is acting upwards? Sine 22.6. So FEF, how much of it is there? It's sine opposite. Minus, because it's coming downwards, we've got our 19.53. Sine 39.81. And then we've also got a 32.5, which is our FFG. Sine 22.6 and all of that equals 0. FBF, we know what FAF is. FBF equals 6.25 kilonewtons. We're saying that FBF is pointing inwards, therefore it's in tension. Sometimes when I look at these arrows, if I draw the arrow like that, if I imagine it going inwards, I look at that line there and I think of tension. So that arrow inwards, I always think of it that looking like a T for tension, where outwards is compression. Don't know if that helps any of you. Right, two more joints, joint B and joint E for our check at the end. So if I just add what information that we've got. Right, FEF, we've just worked out that one. So they're pointing outwards. That's 48.8. C. And FBF, this one here, pointing inwards, 6.25. That's in tension. So we've got B, E and A. Actually A is left also. Joint B, this one here. So B, we have 12.5. We've got this angle, gamma, which is 51.34. Got 45, which is our BC. 6.25, which is our BF. And you've got BE. And we do know what it is. Off we go again. It's in tension. BF. Okay, so sum of forces. Say ups, positive, equals 0. Minus 12.5. This one here because it's coming down. So imagine again that B is staying stationary. So minus 12.5 coming down. Our 6.25 is also coming down. Our BE, let's assume because both of these are coming down, is going up. So it's going to be in compression. F, B, E, sine 51.34. If we work that out, FBE equals 24.0 kilonewtons. It's pointing, the member itself, the arrows are pointing outwards, so it's in compression. Sum of forces, x direction, and see that everything to the left is positive. 45.0, that's BC. Let's assume, because BE is going to the right and BC is going to the right, let's assume that BA is going to the left. That 51.34 is the angle gamma. So minus force in BA, that we don't know what that is yet. And then we've also got this 24.0, this is our FBE. And how much of that is acting horizontally? Cosine 51.34. All of that equals 0. Our only unknown FBA equals 60. and tension. So that's joint B. Let's help whoever's checking the work. Joint E, so BE, we've got 24. That's in compression. AB is 60. That's in tension. I hope your work's neater than this. Joint E. Let's have a look at joint E. By the end of this, we'll actually have all of the members, and we're doing our check at E. You could do another check at A also to see, when you looked at the horizontal and the vertical, does that 60 equal 60? That's correct. We've got 50 going up and we've got 12.5 coming down, so you can work out what the forces in that member. So this is the last check, so we're nearing the end. So we have E, we've got our reaction of 60, we've got our member there, 48.8, another member there, 30 and 24.0. We don't know what AB is. This angle here is beta. We've worked out before, or you have to work out, that beta is 38.66. And this angle here is 22.6. Some of forces, Y direction, I would say that everything going up is positive. FAE, force in AE that we don't know. Let's double check the arrow down direction. So BE is going downwards. EF is also going downwards to the left. EF. So looking vertically, you've got FA, B, this here, and we're saying that it's going upwards. You've got these two forces that are coming down, so you might as well assume AB is going upwards. You've got 24 sine 51.34. That's the angle here. So that angle is 51.34. That's the angle of BE to the horizontal. You've also got your 48 sine 22.6 equals 0. How do I write the first name? AE. FAE. That's AE. FAE equals 37.5 kilonewtons. The arrows are pointing inwards, so it's tension. we can do a check. Sum of forces. See everything going to the right is positive. What have we got? We've got our 60 going that way. The AE we can ignore because it's vertical. You've got your 24. Minus 24. And only a percent is acting horizontally. So 24 cos the angle. And you've also got minus 48.8. Minus 48.8 cos 22.6 degrees. And does all that equal 0? Well, when you work it out, it actually, this side is 0.045, which for me is close enough, and that's a check. You could do another check at the end. So FAE is 37.5. So now we've got all of the members in, and you could do a check there also, looking at vertically and horizontally. That's the end of this second example.